Hello everyone. We're going to talk about the hydrostatic pressure gradient, which is very important both in calculations of the pore pressure and also when we want to talk about the hydrostatic pressure at the bottom of the wellbore. Pressure gradient, I think we kind of touched on this topic previously. So if you have basically a bucket of water, hydrostatic pressure means that what is the pressure at the bottom based on the density of the fluid that you have. And the famous equation that you know, rho g h, is basically talking about the hydrostatic pressure, and that depends on the density of the fluid, gravitational acceleration, and the height of the water, or at the height at which you are calculating the hydrostatic pressure at, right? So in petroleum engineering, or mostly in drilling engineering, the equation for hydrostatic pressure that we use is this equation is 0.052 density multiplied by the depths, and this depth is reported in feet, this density is reported in gallons, pound per gallons, or we show it with ppg, pound per gallon, and then this pressure is reported in psi, right? So now the density of the water in the lab you measured is the pure water is 8.33 pound per gallon. So based on this you can calculate a pressure gradient, right? So pressure gradient means that pressure gradient definition is pressure divided by depths. That's called pressure gradient, right? So how much pressure changes per feet, right? So if you use this equation, then pressure gradient, or pressure divided by depths, is equal to 0.052 multiplied by the density, right? This is gonna give you psi per feet if you use pound per gallon density here, right? For example, hydrostatic pressure of a fluid at 12,000 feet depth, if the pressure gradient is 0.433 psi per feet, which is for water, it's going to give you 5,196 pressure, right? If you change the density to 14, on the other hand, then you're going to get 8,000 psi, right? So any mud density that you have, if you multiply that mud density by 0.052, you're going to get the pressure gradient for that mud. Specifically for water, if you multiply 0.052 by 8.33, that's going to give you 0.433 psi per feet. So that's going to give you the pressure gradient, right? So that's the equation that we discussed. And why do we talk about this? Because, for example, you have a formation which is 10,000 psi, right, at some 12,000 feet, right? Then you want to see what mud density you have to use at that depth in order to be able to keep the formation fluid inside the formation. So that's the minimum hydrostatic pressure that you need at the bottom, right? And that is very important in drilling engineering to design what mud you need to use in terms of density or other properties. This one gonna give you the mud weight, right? So in this case it's 10,000 psi, 0.052 multiplied by 12,000 feet. That's the mud weight that you need to use, 16.03 pound per gallon. So this is an important equation, and please make sure you understand this equation. And I guess in the next video I'm going to talk about the whole problems.